I wanted to say something else also about the exponential functions placed on electron wave functions and the probabilities of tunneling further than a few nanometers and so on that we've proved fairly rigorously with experiments. However, what I think is really going on via this principle of non-local realism, which has now received recognition with the Nobel Prize and has been recognised as a second quantum revolution. What I really suspect is going on is that an electron on one side of the potential barrier, which by the way is constantly tunneling between different locations, constantly interacting with particles in the background, constantly, via this sort of Montevideo interpretation of quantum mechanics, constantly interacting with photons. Then via the uncertainty principle, its position is being measured with great precision by photons in the background. So its momentum, this p-value, becomes very uncertain, which means simply that it's moving at some velocity speed or velocity, whichever you like. It's not necessarily got direction, but perhaps we can use velocity on a level as the term, extends faster than light. So that electron tunnels to somewhere else in the universe, and because of non-local realism, it is not necessarily the same electron that takes its place. So what is left, very briefly, when an electron tunnels in this manner, is a complete void, a configuration space in which there are no particles at all. There is no particle of radiation or energy or matter or anything like this. It is just a perfectly sterile vacuum. And what I think is happening in these electron tunneling experiments is that this configuration space, this vacuum, is actually crossing the potential barrier, and it can only go a few nanometers because it is almost certain that within the few nanoseconds, or the almost instantaneous velocity of it, not even nanoseconds, that it takes to cross a potential barrier, a new particle takes its place, yet another electron. And we simply say, due to our naivety, that it is the same electron taking its place. So this so-called electron tunneling is really just a very convincing illusion. Via non-local realism, we have to invoke the notion that it is indeed not the same electron each time for any event of electron tunneling, be that around an atomic nucleus with the electron volume probability density. Each time we observe an electron, we have no good enough reason to suspect that it's the same electron each time. So what we have en masse, when considering a number of electron volume probability densities taken from a Gestalt perspective, from this holist perspective, if you like, what we have is a field of electron, this electron field smeared out over space, where there's any number of different places that an electron from that field can sort of show up. So I suspect that what is really going on here implies some sort of union between the electrostatic electron field with the electromagnetic field, with the gravitational field also, and that really gravitation is merely attenuated electromagnetism to the tune of about 4.17 times 10 to the 42nd power or so, and the likelihood of an electron tunneling beyond the van der Waals radius of any given atom is about that same value. Very unlikely, but nonetheless, given enough tunneling events and so on per second, given enough electrons within the system we're studying, such as the planet Earth, so it becomes a reliable certainty, and many tunneling events happen per unit of the time differential, whatever we set the time differential to be that the Planck time or whatever other sort of unit of time we're invoking for the average amount of time an electron stays in a given position before it inevitably interacts with a photon or some other particle from the background. So building on this, what can we deduce about this configuration space crossing? Well, I mean, what also needs to be said about this configuration space crossing the potential barrier? Why does it cross the potential barrier at all? Well, I suppose on one level we have to take into consideration the fact that the configuration space has nothing to motivate it to move through space other than factors such as Earth moving along a bivector. Earth simultaneously rotates around the Sun, so that's one sort of vectorial path it travels. Then likewise, the Sun is moving around the galaxy, so it's on a bivector like that. It also rotates. So the sum of these different paths of motion create what am I looking for? What word am I looking for? Create a confluence of movement or motion in the, I suppose, the equations of motion which govern such things that shifts the configuration space some unit of distance in space pretty much instantaneously. And then an electron, which again, our naivety, we believe to be the same electron, pops up on the other side of the potential barrier. And there's other evidence to support this idea that electrons may tunnel just a bit further than a few nanometers. We, for instance, have managed to tunnel magnetic field up to 14 centimeters, I believe, or 12 centimeters or so, which is rather a lot more than nanometers, rather a lot more than the nanoscale. And when it comes to that, I would have said that magnetic fields are tunneling electrons, like in the model I propose, these electron densities with all of the spin configurations of the electrons pointing in one direction, thereby creating magnetism, and the magnetism created it ultimately comes down to the movements of photon fluid, the magnetohydrodynamics of the field, if you see what I mean, of flows of photon moving between background electrons. So fundamentally in electromagnetism, what we have, like, for instance, when you got a bar magnet, like these physics experiments we do at school, for instance, we know that the spin orientations of the particles within the magnetic field are all pointing in one direction. For instance, spin up would be the positive end of the bar magnet, or the electrons orientated spin down. We sort of understand this, I think, from electromagnetism. If we've learned the lessons of electromagnetism well enough, I think that is apparent, is it not? So yeah, but also we have the more advanced notion of the hydrodynamic properties of magnetic fields. So I think when you're looking at this from the perspective of quantum field theory, quantum electrodynamics, invoking those sorts of terms or those sorts of ideas, then what interactions such as electromagnetic behavior need to coalesce upon is this fundamental interaction between photons, these particles of electromagnetism, and electrons in the background, since that is the essence of quantum electrodynamics. And the challenge of quantum gravity, I think, integrating quantum electrodynamics with general relativity and updating general relativity, as Feynman said, with quantum assumptions, this quantum upgrade to general relativity, means we need to put quantum electrodynamics at the heart of a theory of gravity somehow. So the only way of doing that, really, is to make the electron a fundamental component of gravitational fields, gravitational interactions, and furthermore allow it to accommodate for electromagnetic behaviors and to be able to explain phenomena such as magnetic fields using a model built upon the quantum behaviors of agglomerations of tunneling background electrons. That is, I suspect, the only rational synthesis we can derive from this endeavour in quantum gravity. And what we will end up discovering, I suspect, is not new physics, not new particles, that the graviton won't be anything new. it will be the particles we are already aware of behaving in ways that we're not yet used to. That will be the new physics, not additions to the standard model, but very possibly shortenings of the standard model and making it work in a way that is a bit more elegant and efficient, and that uses fewer assumptions, not more assumptions. The thing I hate most about physics is these constant bolt-ons of particles, these crude additions to theory, and just fattening out the standard model with a new particle of this, new particle of that, new particle of this, new particle of that, and invoke the Einsteinian or Spinozan God, as Einstein himself even did. I suspect that it's inelegant. It is not how the universe behaves. The universe is nothing if not elegant. So we must take Occam's razor seriously, I think, and never multiply entities beyond necessity. And the more I think about this, because it's been a big sort of barrier to my theory getting accepted, this sort of objection. And it's come from numerous sources, from well-educated people, from people who have taken in the dogma of physics, really. I think without having really questioned it too much, and it is so important to question established theory and being able to move forward with theory. If we sense that there is a blockage to progress on some level, and something needs to be removed from our models so that we gain better understanding of how the world around us works. And I think also of the so-called cranks, crackpots, crazies, tens of thousands of which have come up with syntheses, of gravitation with electromagnetism, just thinking that they must go together. Gravity on some level must be electromagnetic. And I just think, well, of course it must be. Of course gravitation must be, to some extent, an electromagnetic phenomenon. I don't see why why the universe would seem so arbitrarily thrown together as to have a synthesis of three forces: the strong, the weak, and electromagnetic force. But then gravity, for some reason, operates differently, and we've got this sort of space-time as a trampoline notion from somewhere, not really from Einstein, I don't think, who had an incredibly hard time of giving up the ether. And this idea, it does revive the ether also, which was an idea taken seriously by everyone from Isaac Newton to Michael Faraday and everyone in between. No one really questioned the ether until Einstein came along. And Einstein held on to the idea. And really we sort of do still hold on to the idea. And from quantum mechanics, from this Montevideo perspective, this perspective of the environment causing the collapse of the wave function, which indeed I suspect it does. This constant interaction between electrons, say, and particles in the background, and other fermions constantly interacting and exchanging bosons with one another. This energy economy of the universe. And that is the fundamental behavior of nature. This tendency of the particles of energy, the bosons, to interact with and be exchanged by the particles of matter, i.e. the fermions. So, that at a fundamental level, that's what I believe is going on. And it sort of tells us not much that is really new. It tells us some things that are new, and those things are really important, I think, and really important to grasp. But it sort of makes everything fit together neatly, I think. And it makes the universe elegant again without these bolt-ons. And for instance, in thinking about the graviton, I came up with this conception that it was W plus and W minus particles, being exchanged between these background electrons and nuclear protons within atomic nuclei, and it gets within the electroweak range, and it swaps a W minus from the electron for a W plus from the proton, and in the interim, the W plus and the W minus mutually attract, forming a spin-2 gauge field. So they've both got a spin of 1. You get a composite graviton, but we'd never be able to recognise it as such. And crucially, the mutual attraction between those two particles cancels their masses to nothing, meaning like our original models are still correct because we call this process the exchange of photons. What the W pluses and minuses become are indistinguishable from photons. So we get this shape shifting also of bosons. I also suspect the gluon isn't really a fundamental particle. I think it's probably photons trying to force nuclear hadrons apart and exciting nuclei, getting trapped within nuclei, just bouncing around in there, being exchanged by the particle, getting trapped and exchanged by the quarks really that are within the nuclear hadrons, and from these interactions between background electrons and nuclear protons, and I suppose to somewhere, and so you get neutrons in there as well, but yeah, that this creates a binding energy for the nucleus. So we get a kind of electro-strong interaction, or gravito-electro-strong, or gravito-electro-weak, or gravito-electro-streak, if you like, and that's a terrible thing to call it. It should never be called that. I hate that. That's terrible. No, electro-weak strong or something, or gravito-electro-weak strong. It should be called, but yeah, and like really, when it comes to protons and neutrons in the nucleus, like it's just an agglomeration of quarks, isn't it? It's a quark-gluon plasma, more or less, sort of going on in the nucleus. It's not so starkly delineated as neutrons and protons. The whole nucleus is obviously positively charged to a greater or lesser extent, depending on what sort of atom it is. You know, I suppose like uranium-235 or whatever will have a positive charge of 235 for its nucleus, and hydrogen will have a charge of 1 in most cases, but well, in all cases. But yeah, it's not like it's just the way we define things like protons and neutrons is a little arbitrary in a way when it comes to nuclear physics anyway. And I think that's roughly speaking what I wanted to say about it. It's more about like trying to see beyond the hard mathematical lines we draw upon things and seeing the beauty of nature in the way we look at systems in nature, and not trying to reduce everything to mathematics. Since mathematics, I'm afraid to say, we call it the language of nature. We say that nature is written in beautiful mathematics, but like nature is more beautiful than the maths, I think, and the maths is very often misleading, because mathematics is ultimately a language created by humans to try and understand nature. It is a very useful tool. I don't deny that. It takes us an incredibly long way in terms of understanding, but it can mislead. Sorry, I've got to go. Thank you for watching.